Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to optics in the chapters of lenses and formation of images. This exercise was a previous one in the Brevet exams in 2015, first session, first exercise. The title of this exercise is Focal Length of a Converging Lens. The aim of this exercise is to determine the focal length f1 of a converging lens L1. For this, we consider an object AB of size AB is equal to 4 centimeters, a screen E, the lens L1, and a set of converging lenses of known focal lengths. So part 1, we place AB perpendicularly to the optical axis of L1, A being on the optical axis at 60 centimeters from L1. The image A1B1 of AB is obtained on the screen E as shown in figure 1. So they mentioned the figure, so now I can use it. Then number 1. In number 1 they are telling me redraw with the same scale the above figure. So notice that here in the figure the direction of propagation of light is not indicated, but from these arrows on the incident ray and on the emergent rays we can know that the direction of propagation of light is from left to right. And always whenever we need to redraw we always start by drawing the optical axis at the middle, having the same direction of propagation of light. Then we place the lens L perpendicular to the optical axis at the center using the correct symbol of a converging lens. And the intersection between the optical axis and the lens L is the optical center O. And this is the lens L1. Okay, and now the point A is located on the optical axis in front of the lens by 1, 2, 3, 4, 5, 6 divisions. Then 1, 2, 3, 4, 5, 6. This is the position of the point A. And the point B is located 2 divisions above A. Hat is found on B. Now let's trace the object AB. And now the screen E is located 1, 2, 3 divisions behind the lens. So 1, 2, 3. The screen E is perpendicular to the optical axis. Moreover, the point A1 represents the intersection between the optical axis and the screen E. And the point B1 is found 1 division below A1. The hat is found on B1. And now let's trace the image A1, B1. BO represents an incident ray issued from B, and OB1 is its emergent ray. And we don't forget arrows on light rays. The scale is given by 10 centimeters along the x-axis and 2 centimeters along the y-axis. Okay, hope we didn't forget anything. Now in number 2 they are telling me the ray BO emerges from L1 without deviation. Justify. Since the ray BO is passing through the optical center, then it will emerge without deviation. Then let's justify that an incident ray issued from B passing through the optical center emerges without deviation. So now we are in number 3, part A. They are telling me specify the nature of the image A1, B1. Okay, notice that here in the text they told me that the image A1, B1 of AB is obtained on the screen. Then the image is being collected on the screen, and we know that only a real image can be collected on a screen. Then let's say that since it's collected on the screen, then the image A1, B1 is real. And now in part B they are telling me give the size of A1, B1. So in other words, we need to determine graphically the size of the image. Then let's write size of the image A1, B1 Now A1, B1 consists of one division, and we multiply by the scale along which we have counted the number of divisions, which is scale along the y-axis, and this will give me 2. Since the scale is in centimeters, then the value of A1, B1 is in centimeters. Always all quantities in physics must have unit. Finally, it's a good habit to write our final answer in box to make the task easier for the corrector to notice our correct answer. Okay, so this is it for part B. Now in part C they are telling me determine the distance D1 between L1 and A1, B1. So D represents the distance between the lens and the image. Then part C, distance between L and A1, B1. Now this distance is denoted by D1. We use the same notation, and it consists of 1, 2, 3 divisions, and we multiply by the scale along which I have counted the number of divisions, which is scale along the x-axis, and this will give me 30. Since the scale is in centimeters, then the value of D1 will be in centimeters. So D1 is equal to 30 centimeters. And let's write this value here. Maybe we'll use it in the second part of this exercise. And now we have reached for part A. In this part they are telling me using a particle array, determine the position of the image focus f'1 of L1. The word determine here means that we need to trace and justify at the same time. Then we need to determine the position of the image focus using a particle array. Then we need to trace this ray and justify its path, and we need to trace the image focus and justify that as well. We know that always incident parallel ray is related to the image focus. Then let's consider an incident ray issued from B and parallel to the optical axis. And we don't forget arrows on incident rays that indicate the direction of propagation of light. We know that this ray will emerge passing through the image focus. However, in this case we don't know the image focus, we know the image B1 of B, and we know that all rays issued from B emerges from the lens going to B1. Okay, and we don't forget arrows on light rays. Now let's justify the path of this ray. An incident ray issued from B parallel to the optical axis emerge is going to be 1. Okay. Now what we have done so far is the tracing and the justification of this particular ray. Now we need to trace and justify the image focus f'1. So because this ray is parallel to the optical axis, then it will emerge passing through the image focus. This is the emergent ray and this is the optical axis. Then the image focus f'1 represents the intersection of the emergent ray with the optical axis. So this is f'1. Now let's justify it. Then the image focus is the intersection of the emergent ray with the optical axis. Then done for part A. Now in part B they are telling me deduce that f1 is equal to 20 centimeters, and the word deduce means that we need to use the part just previously before, which is for part A. Now in part A we have determined the position of the image focus f'1 and we already know the position of the optical center, therefore we can determine graphically the focal length f1. And by referring to its definition, the focal length is given by the focal length is the distance from the optical center to the image focus. Now the focal length is denoted by f1, and it is the distance from the optical center, which is the point O, to the image focus, which is the point f1 prime, and we don't forget the bar because this distance may be positive or negative. And now f1 is equal to O f1 prime bar, so it is the distance from the optical center to the image focus f'1, and notice that this distance is in the same direction of the positive x-axis, which means it is positive. And now we count the number of divisions between O and f1 prime bar. We have 1, 2, and we multiply by the scale along which you have counted the number of divisions, which is scale along the x-axis, and this will give me 20. Because the scale is in centimeters, then the value of f1 will be in centimeters. Finally, f1 is equal to 20 centimeters. Okay. Then the focal length f1 is equal to 20 centimeters, which is a positive number, which verifies that the used lens is a converging lens, because we know that for a converging lens, the focal length is always positive. So this is it for part B. Now in the second part of this exercise, they are telling me we perform the preceding experiment again by replacing L1 successively by each of the converging lenses of the given set. For each lens, we determine the distance d between the lens and the image of AB. The curve of figure 2 represents the variation of d as function of the focal length f, knowing that the object AB being always in the preceding position. Okay, they are telling me using the graph of figure 2. Number 1, they are telling me indicate whether d increases or decreases when f increases from 10 centimeters to 40 centimeters. Justify your answer by choosing 2 points from the curve. First of all, the word increases means that the values are getting larger, and the word decreases means that the values are getting smaller. Okay? So we need to specify whether d increases or decreases when f increases. Then let's write down as f increases. Then we need to specify whether D increases or decreases when F increases from 10 centimeters to 40 centimeters. This is 10 and this is the 40. These are the values of F, 10, 20, 30, 40. So this is the increasing sense of F because the values are getting larger. We need to justify our answer by choosing 2 points from the curve. This is the curve. Okay, then let's choose 2 points. The first one is 20. Notice that for F is equal to 20, it corresponds to this point on the curve, which corresponds for D is equal to 30. And for F is equal to 30, it corresponds for this point on the curve, which has a value of D is equal to 60 centimeters. Then the value of D corresponding to these 2 points are given by 30 and 60. Then let's say that D varies from 30 centimeters to 60 centimeters. And notice that the values of D are getting larger, which means that D increases as F increases. Then let's say as F increases, D increases. And now we are in number 2. They are telling me determine again the focal length f1 of L1. So we need to use this graph in order to determine the focal length f1 of L1. Notice that this graph represents the variation of D as function of f, in which D represents the distance between the lens and the image, and f represents the focal length of the used lens. So if we know the distance between the lens and the image, we can determine graphically the value of the focal length. Then let's write down graphically. And from the first part of this exercise, we have determined the distance D1 between L1 and the image, which is given by 30 centimeters. Then let's say that we have, or for D1 is equal to 30 centimeters, we have D is equal to 30 centimeters, corresponds to this point on the curve. This is the curve, which has a value of f is equal to 20 centimeters, and the focal length is denoted by f1. So we have f1 is equal to 20 centimeters. Therefore, f1 is equal to 20 centimeters, which is the same result that we have determined in part B. And by this we have finished solving this exercise. I hope it was beneficial for you guys out there watching it, and see you soon in another one.